Hey guys, it's pajama day today. What do you guys think this looks like? A bunny or a cat? Because Hudson, my 3-year-old, said it looks like a bunny. So just wondering what you guys think. Maybe we should do a poll later. But anyway, so good morning. I am going to teach you guys about one of my favorite things ever, and that is the normal distribution or the normal curve. So hopefully the previous 2 assignments that you've done, where you're probably like, what in the heck? I don't even know any of this. What is she asking? It was more of trying to figure out for yourself what a normal curve looks like. So hopefully by now you have figured out, well, a normal curve or a normal distribution, those mean the same thing, is symmetrical, and it is referred to as the bell-shaped curve. Oh, I was also going to tell you guys, you should get out your notes. And I would probably write down all this information right here. I will also have a PDF on here that you can print. So if you just want to print my notes after, you can. Otherwise, I'd pause this video right now, get your notebook out, write it with me. Anyhow, so we know that it's symmetric, and we know it's shaped like a bell. That's like the nickname of it. And it's defined by the mean or the average, which is denoted by this Greek letter mu. Yes, I just said mu, not meow, not moo, mu. So I think it's like mu is how you spell this. But anyways, it is a Greek letter because Greeks just love math, you know. And the standard deviation, sigma. That's the Greek letter sigma. So because the last assignment you guys did is you had 3 normal curves, and they either had the same mean and different standard deviation or vice versa. And then you said how it affects. So remember, the mean affects like where the center is at, right? Along the x-axis. The standard deviation, which I'll probably just refer to as SD because, you know, I'm lazy. Standard deviation, that takes a lot longer to say than just SD, but you know, that affects the shape of the curve, how spread out the numbers are, right? So the smaller the SD, the closer they were, or the higher the curve, some of you said. Some of you said it affect the steepness of the curve. Yeah, that works. Anyhow, so that's what a normal distribution is defined by, just those 2 things, average and the standard deviation, or mean and standard deviation. So the area that's under the curve, that can represent the probability. So this is tied to probability, which we started with the total area equal to 100%. Okay, so the next important thing about the curve that you're just going to practice using is, and this is, remember this keyword right here, approximately, means it's always roughly. Not every normal. Uh-oh, somebody's yelling. Hold on, I gotta pause. All right, sorry about that. I got pulled out in the hall. Okay, so now this word approximately means not every normal curve is the same. I don't know if I just said that, but so this would be approximately 68.2% of data falls within 1 standard deviation of the mean. So that 68% would go from 1 standard deviation below and 1 standard deviation above the mean, okay? That's 68.2. And I'll show you each percentage. I'll write down that in just a couple seconds, minutes, whatever. So the next one is approximately, I think it's 95.4. Let me check. Yeah, 95.4% is within 2 SDs of the mean. So that means if you went, here's the mean in the middle, right? The highest point. If we go 1, 2 SDs below, 1, 2 SDs above, that would be about 95.4%. And then the last one is going to be nearly everything. 99.8% is what it rounds to. So then that would be 3 SDs below the mean and 3 SDs above the mean. So that's saving a little bit of space for these outliers that are just way above the mean or way below the mean. So the empirical rule, whenever I refer to the empirical rule, the shorthand version, because we don't like to say the tens place, we're just going to call it the 68, 95, 99. It's actually 0.7 rule, but it rounds to 0.8. So anyway, but this is what it's referred to as. So the empirical rule or the 68, 95, 99.7 rule, okay? So I'm going to erase that. I'm going to give you the individual percentages in each of these sections of the normal curve, because that's what you're going to use to answer the questions on the quizzes assignment. So if 68% is within 1 SD of the mean, well, about 68.2, if we split that in half, because it's symmetric, then we would get 34.1%. Is from the mean to 1 SD below and mean to 1 SD above would be 34.1. And then this one, if we did 95.4, we subtracted the 68.2 and divided by 2, we'd get these sections, which is 13.6%. So hopefully you're writing this down, because you don't have to memorize these. Okay, I would like you to just memorize this overall rule, like these numbers, but then the individual sections, totally use your notes for it, because I just want you to understand how it works and answer the questions using your notes, okay? Let's see. Even if I said you couldn't use your notes, you guys probably would, so let's be honest. All right, and then this section right here is going to be 2.2%, and then this little section right here, which I'm going to draw an arrow, is 0.1% of the time. Okay, so that is the section between each standard deviation, or the percentage between each standard deviation. So now we're going to use that to answer these questions. Okay, so if you want to just listen, you can. If you want to actually draw this example too, totally up to you. But here we have the weights of 50 football players. They follow a normal curve, or approximately follow a normal curve, because it doesn't have to be exact. And there's a mean of 178 pounds and a standard deviation of 8 pounds. So if I'm labeling that, see, this is where I think it's most important. If you know how to just draw and label a normal curve, that would be awesome. So the mean is in the middle. So I'm going to do 178 pounds right there in the middle. And then if I go 1 standard deviation above the mean, that means I'm going to add 8, because 8's my standard deviation, right? So I'm going to add 8 to the mean. 178 plus 8 is 186. So that SD would be 186. Then I add another SD, because this is going to be 2 SDs above the mean. So plus 2 plus 1 SD plus 3 SDs. Okay, so then I add another 8 to 186, and that would be 194. And then I add another 8, and that would be 102, I think. 102. Guys, going crazy. 202 pounds. Ugh. Okay, and then the same thing here. So right here is going to be minus 1 SD, minus 2 SDs, minus 3 SDs, okay? So minus 1 SD would be 170, right? 178 minus 8. Then we go 170 minus 8, 162. Subtract 8 again, I get 154. Okay, so now that I have it labeled with each SD, now I can use this curve with my notes here to answer these questions, okay? Let's do a different color. Ooh, let's do galaxy color. Ooh, that's pretty. Okay, so what percent of the players weigh between 178 and 194? So 178 is the mean, and 194 is 2 SDs, right? So I'm wanting this area. I'm going to shade it in for just a second. Look how cool this pen is, you guys. It's rad. Is rad even a cool word anymore? Probably not. Anyway, okay, so I'm finding the percentage from 178 to 194. So then on my notes here, it's just from the mean to 2 SDs above. So I'm just going to add 34.1 plus 13.6, and I'm going to get 47.7, I think. If I added that right? I think so. Okay, so 47.7% of the football players weigh approximately between 178 and 194. Okay, change colors. Let's do. So now, what's the probability a player weighs at most 170? Ooh, that's a key word there. So at most 170 means that's the most they weigh. They don't weigh more than 170, right? So at most means that's going to be the highest, and we're finding the percent below 170, right? So then 170 would be 1 SD right here. So I'm going to add up from here and all the way down. So that'll be 13.6 plus 2.2 plus 0.1. So it's going to be 15.9, I think. I did my mental math right. Yeah. So about 15.9% of the football players weigh at most 170. All right, moving on. Next problem. Let's just do black, I guess. So what's the probability a player weighs less than 162 pounds or greater than 194? Now it's getting tricky on us. So less than 162. So that would be from here to here, right? I want that probability. Or greater than 194. So then I go here to here. So I'm adding in basically those percentages that are farther than 2 SDs away from the mean. So it'd be from here below and from here above, which it's the same thing. It's just 0.1 plus 2.2 plus 0.1 plus 2.2, right? Or I could go 0.1 plus 2.2 and then multiply by 2. But so that'd be, I think, 4.6% of the players, right? 2.3 times 2. Yeah. All right, last problem is, let's see, let me get a different color. Ooh, what's this? Rainbow. Okay, how many players weigh between 170 and 186? So 170 is just 1 SD below the mean, and 186 is 1 SD. Oh, wait, that's 1 SD below and 1 SD above. I know what that is. That's this right here, 68.2. I don't even need to do anything else because I know that's 1 SD below. Oh, guys, that pen is so cool. So 1 SD below and 1 SD above is 68.2% of the players. Guys, we need a pen that really writes like that. That would be so cool. Okay, so I want you to use your notes, practice just reading the normal curve, understanding how to label it, things like that. And there's an assignment on quizzes that you can take as many times as you need until you fully understand this. And if you have questions, please email me, message me in Canvas on Remind, and I'll talk to you soon. Have a good day.